So it's part 3. We've built a few node files. I've pushed them up to GitHub. They're in the new COMP2106 Winter 21 repository if you need them. Our web server and our hello world. So we're going to try out some blocking versus non-blocking examples. So we're going to make a couple of files first. So I'm going to right click and I'm going to make a new file here. It's not going to be a JavaScript file. It's just going to be a text file. So I'm going to call this file, we'll call it food.txt. Okay, so make a blank text file called food.txt and tell me what you've eaten so far today. Let's make a list. Let's populate this list with some food. Okay, waffles. What else have you eaten today? Eggs. I had made myself a very good breakfast burrito. Spaghetti. What else? I'd like to get 10 or 12 items in here. Toast. Ivan, did you eat those together? Cereal and spaghetti. Bagel. Thanks, Barack. Okay, Nick, we're going to divide those. Cherry cinnamon cake. That sounds good. Did you make that yourself, Nick? We'll come back to your espresso, Nick. Ah, lucky you. Okay, let's get a couple more items in here. 2 or 3 more things. What else have you eaten today? I did have a banana first thing this morning. Anybody else? A couple more food items we can throw in our list of what you've eaten today. Pancakes. Okay, maybe one more item. All right. Rebecca, I'm jealous. I finished my hash browns last week. I actually had poached eggs on hash browns for breakfast, which were great. Really wanted to have them today. Had to settle for the breakfast burrito. All right, and avocado. Yeah, I have some of those on my breakfast burrito too. Great. Okay, so save that list. I'll throw it in the chat if you like, if you want to just copy it. So there's our food.txt. I'm going to make a drinks.txt. So I'll make a new file called drinks.txt. So Nick has had an espresso. Maggie, we've both had coffee, water, milk. I had a green tea to start my day. Okay, Janelle, you had tea as well. Oh, chocolate almond milk. All right. Good list. So we'll save that. Thanks, everybody. So we've got food and drinks. So we want to write 2 different node files, both of which read from these lists and then output the lists. Okay? So make your food, make your drinks. Doesn't really matter if you have these items, but the 2 files, we want the first file to be longer than the second one. You can really put whatever content you want in there. Okay. So now we're going to make our blocking.js file. So we'll make a new JavaScript file, which we'll call blocking. So we want to include nodes built-in FS, which stands for file system module, so we can read text files. In order to be able to read the food and drinks, so create a variable called FS, and we'll require the FS module. So we want to read the food and the drinks text files and just output the contents to the console. So we're going to read the two text files and output the contents. So I'm going to create a variable called food, and we'll set it equal to, we want to read, we're going to read the file synchronously. Remember, this is our blocking version. So our read file sync takes two parameters. What file are we reading? And we also have to provide some encoding. So it's just a simple text file, so we'll use UTF-8 encoding. So that's going to open our food file and read the contents. We'll then log out our food variable. So we could actually try the file right now. And if we do, this should read our food list of food and print it out to the console. We'll try it. So I'll open up my console. I'll type CLS just to clear it out. So how could we run this file to try and read our text file and display the list? Yep, thanks Maggie, right? We can run node and just the name of our file. So there we go. It spits out the name of all the contents of the file. So we know our read file sync is working. So what we want to do next, let's print out another message here, a little text message. Say we ate this stuff, and then a carriage return, a new line. So this will print the food and it'll print this message at the bottom. If I want to run the file again, I could just hit the up arrow, or I could type the node space blocking command again. Right, so it prints our list, and then it prints a message at the bottom. We now want to do the same thing underneath in our file. We want to read the drinks, print out the list of drinks, and print a message at the bottom that says, we drank this stuff. So I'll create a second variable called drinks. Again, we're going to read, oops. This time we're going to read drinks.txt. And we're going to log out the contents. So what do you predict? What is the output going to look like if we run the file again? What do you expect to see in the console? Okay, so the list of food And what about the messages? Where do you think those will appear? Whoops, sorry. Okay, so you said, Rebecca, at the bottom of each list. Janelle, yeah, you said the bottom. I'm assuming you're meaning the bottom of each list. Let's try it again. So let's hit the up arrow. And what do we get, right? The list of food, our message, list of drinks, and our message. Right, so the code is blocking that it has to read and print all of the food items first before it gets to this line. Then it's got to open the drinks file, read everything, print them out before it gets to this line. So everything's happening in a blocking manner. Each process happens, no process can start until the previous process finishes. Okay? So this is kind of what we're used to. Our code happens in sequence and nothing can start until the previous thing has finished. We now want to try this version where our code is non-blocking. We want to try and read them at the same time. Okay. I'll just put this code up on Pastebin for now if you need it. Any questions so far, or is this fairly straightforward? So we want to try and, okay, good, thanks. If we're calling read file, yes, that it's a required parameter, good question, Maria, of the read file. Needs to know if we're reading it, what encoding is there. So now we're going to use asynchronous code, and we're going to use this callback structure. So let's create, this is the last file we're going to do for today. So we'll create one more JavaScript file. We'll call this non-blocking. Again, we want to include nodes, file system, library. So our first line, again, we'll create an fs constant and we'll require the fs library that gets added to our machines when we install Node. So now we want to read and display the food list. So we'll create a variable called food. And this time, instead of calling read file sync, we're just going to call read file. So by default, the methods in Node are asynchronous. And the parameters are mostly the same. First parameter is going to be what file are we reading? We're reading food.txt. Second parameter, again, will be the encoding. But this time, our third parameter is going to be a callback, right? So that's going to let this function run asynchronously. So while it's running, we can do more things, and then we can come back here. So when we call read file, what two things could happen when we try to open a file in the file system? There's two possibilities. What could happen when we try to read a file in the file system? Yeah, we could get some kind of error. That would be one thing. What would the other thing be? So yeah, either it's not found, the file is locked, we don't have permission. Yeah, or we open the file. So in here, our callback has two parameters inside. The first one is an error. So I'll just call it error. So what happens if for some reason we can't read the file And the second one, I'll define as food. So this is in case we do get contents back. And this is where we're going to use our lambda or our fat arrow expression, fat arrow function. So because this is asynchronous, add a third callback parameter. Parameter is an anonymous function that either returns an error or the text file contents. Yeah, Nick, you know what? Good point. Sure, we could use let. We're not going to change it, so that would be fine. Yep. Good suggestion. So once this is done reading the file, we'll want to log out. If we don't get an error, right, we'll want to display the contents represented here. We'll say, we ate this stuff. So let's leave the drinks out for just a minute. Let's just run the file this way. What do you think the output is going to be if we try and run the file in the console? Okay, Maggie thinks same list than the message. Other predictions? Do you agree with Maggie? Do you think that it might be different? Well, let's try it. So now we'll run node non-blocking. So what happens and why? Yeah, so in this case, how is it that line 11 gets printed before all the food? This is, you're seeing asynchronous code in action here. Rudia, that's right. So even though we start reading the file, yeah, Rebecca, that's the other part of the answer. So good answers, Rudia and Rebecca. So it's not waiting for this to finish. And this is faster, right? It takes some time to read that list of food and print it out. So, and because this is asynchronous, this code doesn't block. So it, as Rudia says, it doesn't wait. As Rebecca said, this happens first because it's faster, takes less time than to read the contents, even of our, even a small file, only 12 lines. It still takes longer to open that file, read the contents, and display it than it does to run this one line, right? So it can, the node is processing both of these things at the same time. But the key is this weird syntax of the callback function. So start reading the file, but come back here and do this when it's done. And in the meantime, go and do the next thing. So let's add the drinks to this page as well. So we're going to do the exact same thing with drinks. We're going to read file. Again, we'll either get an error or we'll get a list of drinks back. When we're done reading the file, if we get data back, we're going to log it out. Okay, so I'm just copying everything, just changing food to drinks. 4 changes. What's your prediction when we run the file now? Right, we've got 4 outputs, right? Our 2 messages and our 2 lists. So what order do you think the outputs are going to display now? So Rebecca, you think the 2 messages and then the 2 lists. Rubidia, you agree? And then the food and then the drink? All right, well, I'll hit my up arrow. Okay. So yes, Rebecca and Rudia, right again, right? It prints both messages. We ate, we drank. But notice which list displays first. Yeah, it prints the drinks first. How come it prints the drinks first? Yeah, because it takes less time to process, right? So actually the first thing we started doing is the last thing to complete. Yeah, Janelle, right, because it's, and Rudy, you're right, it's shorter, less data. Even though we start this first, so in a blocking method, right, in our blocking file, nothing else happens until we're done reading and displaying the food. In non-blocking, things just happen. We can run all these processes concurrently. Now, there's times we want code to block. Okay, so let's say, for example, yes, with Node, you don't need to write async. This is the equivalent. When you use the callback parameter, this makes it asynchronous. In ASP.NET, we needed to write async and await. That's the .NET. .NET now supports asynchronous programming, but Node did it first. .NET has now added it on to try and keep pace. It's a really good question, Maria. So there are times we want blocking code where we don't want something to happen until something else finishes. Here would be a common example. We're building an e-commerce site, and on our confirmation page, we want to save an order to the database, generate an order number, send a confirmation email. In that case, we want blocking code. We don't want to send a customer a confirmation email until the save to the database is done, right? If we used asynchronous code there, we might have a problem. Because what happens if there's a failure or an error when we save the order, but we've already emailed the customer to tell them, hey, here's your order confirmation. That's going to be a problem. But if we're doing something like one of the common examples he mentioned in the video is, let's say we want to make a call to an API or a web service. Maybe we want to render and do a whole bunch of processing on our page, but we also want to, fetch a piece of non-essential information from an API. So we can call the API and do other processing on our page while we're waiting for a response from that API, but things don't block. So we could load the rest of our page while we're waiting. So the end result of this is much less waiting time and web applications that in general respond much faster by using this admittedly strange syntax. Yes, that's the other thing, Rudia, good question. The read file method by default is asynchronous. Here we explicitly said call it synchronously. So that makes a difference too. It's an excellent question. Now there's one syntax difference in the video that I just want to point out between how I wrote the code and how he wrote the code. Notice here, he wrote function and there's no lambda expression, no equals greater than. In our version, we don't have the word function and we have this instead. This is just the more modern version. The video is old. So I could have written the code like this, and then I take out the fat arrow. It will work the same way. And in the original versions of Node, we would type this. So if we looked in old Node code, like from my lessons and GitHub repositories from 5 years ago, you would have seen the word function in here all the time for all the asynchronous callbacks. We've now moved. So in more modern versions, you see this instead. Instead of the word function before those parameters, we have the fat arrow expression after. But they are the equivalent. This will work the same way. So you see the old syntax here. Yeah, you know what, I'm going to put the whole thing on GitHub in just a second, actually. So when we see these brackets seemingly out of nowhere, these parameters, and then you see this lambda, that tells you, hey, this is a callback. This is an asynchronous callback. I know the syntax is new and it looks weird. It takes a little while to get used to it, but you will. Because we're going to write lots of files, it's going to start to become simpler for everybody. Okay, that's all I wanted to do today. So this is lesson 1, 2, locking versus non. I will push to GitHub right now. Make a new commit. Okay, so everything is on GitHub now. Okay, I promised to set you free early. I am making good on my promise. I'm happy to stick around for a few minutes if anybody needs help or has questions. There's no homework this week, no quiz. I will see most of you Monday for our client kickoff meeting in Project Studio. And if not, the rest of you, hope you have a great week, and I'll see you next Thursday. The code's on GitHub. Videos will be on YouTube a bit later today. If you've got it working, if you have no questions, you're free to go. Have a great weekend.